Okay, I think we can start. First, thank you all for joining. This is the first time we're doing this GFEI webinars on Teams and not on Zoom. So we hope everything goes smoothly, technology-wise. Sofia, if you can just flip to the next slide. So just want to welcome you all. My name is Professor Guy Ziv. I'm from the School of Geography in the University of Leeds, Professor of Socio-Environmental Systems. I work on ecosystem modeling and social science to look at the impact of policy and climate change on the water, food, and energy system. If you can, this presentation is going to be on planting hedges to mitigate floods, and it will be presented by Professor Pippa Chapman and Dr. Sofia Biffi with us today. If you can go one slide back.
Of course.
So this is the previous slide. So this is part of the Global Food and Environment Institute series of webinars. For those who don't know, GFEI, it's an interdisciplinary research community that brings people from academia, industry, and policy to look at food security and climate change. We have in the Q&A part that you can find the link at the top of your screen. You will have, there's a message there from Sarah Dennis that introduces the Global Food Environment Institute. You can find all the links there for future events on Eventbrite, the website, the links to social media, Blue Sky, LinkedIn. Please follow us on any kind of your favorite social media to see get news about future events. Before I introduce our speakers, I just want to remind that this is going to be cameras and microphones off in this town hall type meeting. The presentation will take about 20 minutes. There is a Q&A location. Please write your questions there, and I will moderate the discussion at the end of the session, gathering your questions from that section of Q&A section. The seminar is being recorded, and a recording will be made available via the YouTube channel of the Global Food and Environment Institute. That you can also find the link to that in the message that Sarah Dennis put in. So let me introduce our speakers, Professor Pippa Chapman and Dr. Sofia Biffi. Pippa is a soil scientist working in the interdisciplinary field of land and water management. Her expertise focuses on sustainable agriculture, soil health, soil water quality, climate change, and her research includes measuring and demonstrating the impact of regenerative agriculture on soil health, crop health, yields, greenhouse gas fluxes, water quality, and doing this the trials on the University of Leeds farm. She's co-champion of the Natural Environment Research Council's research program on freshwater quality, and works with colleagues in AFBI, University of Ulster, to monitor the impact on soil nutrients and health scheme in Northern Ireland, as well as loving hedgerows, which we will be hearing more about here, and the ecosystems that hedgerows are delivering. Sofia is an agroecologist specializing in hedgerows and soil and agricultural landscapes. Her research looks at hedgerow planting and biodiversity recovery, soil carbon sequestration, and hydrological functioning. Much of it has been, most of that has been done while she was here with us in the University of Leeds. She's now in Aarhus University in Denmark, continuing to work on climate mitigation strategies in the context of EU regulation. And she recently joined the Center of Nature-Based Solutions at Aarhus University, where she'll be continuing to looking at those questions in a Danish context. So for those that don't know, CNBS is part of the Department of Ecoscience in Aarhus University, led by Professor Nikolai Freiberg. And that includes research around nature-based solutions in general, as well as, Danish context for nature-based solutions. So with that, I will pass on to to Pippa to start the webinar, and I will come back when it's time for the questions and answers.
Thanks, Guy. And as you saw from the previous slide, Guy also was involved in this research along with another colleague, Richard Grayson, based in the School of Geography at University of Leeds. So this was part of a global food security programme and part of the Resilient Dairy Landscape project. And so, yeah, together, Sofia and I are going to tell you about some of the research we carried out and looking at the role of planting hedgerows on hydrological functioning and what that means for flood mitigation. And in particular, natural flood management. And so some of you may be aware that in 2023, the government announced, a new programme looking at natural flood management, £25 million. And this followed on from a pilot study that looked at the role of NFM and between 2017 and 2021. So obviously there's a lot of funding out there and a lot of support from governments, not just in the UK, but globally, the role of nature-based solutions for mitigating different things. And here we're going to really look at natural flood management. So natural flood management uses natural processes to reduce the risk of flooding. And really the techniques are all about storing more water within the catchment and slowing the flow, so the time it takes for the rain to reach our rivers and oceans. And also these techniques that we use, can they deliver multiple co-benefits? And so one of the techniques that's being promoted within NFM is hedgerows. And we can see in the next slide, we can see a number of NFM techniques where hedgerows are being promoted. And here we can see a newly planted hedgerow. And I suppose the aim here is that the hedgerow will be planted across the slope. And so runoff will be intercepted and infiltrate the soil beneath the hedgerow. And also at the same time, we can capture any sediment that water overland flow is carrying, and so reduce the sediment load reaching our waters. So again, here, I've taken these from the website, but here they're highlighting some of the also additional benefits like improving water quality and air quality. It's obviously habitat improvement on the farm and helps with climate resilience. So there's a lot of promotion of hedgerow planting for NFM. And I suppose the questions that if you're a land manager or a farmer, or if you're an advisor, could be some of these. So where in the landscape should I plant these hedgerows for the best sort of flood mitigation role? And does it matter what soil type I plant them on? And how quickly will the soil structure and hydrological function change after I've planted these hedgerows? And how much faster does water infiltrate under hedgerows compared to my agricultural fields? And these are some questions that people have attempted to answer, but some of these questions, like the rate of change, we really don't have much information. And so the aim here, a visual here, is the bottom picture here shows soil that's been taken from different parts actually this is from groundswell, those of you that might be familiar with that event. And you can see soil taken from an arable field adjacent to a grassland field and a hedgerow field. And I think you can visually see that the soil structures are different from these locations. And also we can notice the colour of the soils are very different, and it's much darker, the soil under the hedgerow, and this is because the carbon content of the soil is higher. And so we know that under these different parts of our farming landscape, we have different soil structures, different soil properties, and this is almost likely to lead to different hydrological properties. But what we don't know is the rate at which these properties change. So, and here, as I said, there are some studies that have really looked at infiltration, and this is one that actually I was part of at the University of Leeds farm, and the figure shows the infiltration rate, so the rate at which water moves into the soil, and the higher the number, the quicker it infiltrates. And what we can see is that infiltration is higher under hedgerows compared to margins, which is higher compared to the grassland fields, which is higher compared to the arable. And as I said before, there's a lack of information about the rate at which these soil properties change once we plant hedgerows. So the aim of our study was to quantify the soil physical and hydrological properties under hedges of known ages and compare them to the adjacent improved grassland fields. And here we're using a space for time substitution approach. So we know the ages of the hedgerows, and we're assuming that the changes we see between them are as a result of planting the hedgerows. So this study was carried out in collaboration with farmers in Cumbria, and these farmers were all dairy farmers that were supplying their milk to First Milk and Nestle. And First Milk and Nestle had a private agri-environment scheme where they were asking their farmers to carry out a number of options to help improve the sustainability of their farming. And planting hedgerows was one option, which was very popular among the farmers. And so we were able to find a number of different age categories. And so here you can see that we took the newly planted hedgerows as sort of, they'd only been planted for 2 to 4 years. And we had 8 of these hedgerows. There was then a number of hedgerows that were approximately 10 years old. And again, we had 8 of these hedgerows. And then we had some hedgerows that for this study, we've actually sort of brought together and called them old hedgerows. But there were 8 hedgerows where the farmer knew he planted them approximately 37 years ago. And then the other 8 hedgerows, which we brought together to a group of 16, were a range of ages. Many could be decades or even 100 years old. And we, as I said, collected soil samples at 10 centimetre intervals to a depth of 50 centimetres. And we compared the properties, soil properties and hydrological properties to the adjacent improved grasslands. And we can see here, these grasslands were quite intensely managed. They were predominantly perennial ryegrass. They were cut for silage. They had an application of slurry and fertiliser, and they were grazed as well. So this gives you an indication of the types of hedgerows and the ages of hedgerows. And in addition, we had hedgerows were based on 2 predominant soil types. And now I'm going to hand over to Sofia, who's going to tell you a little bit about the results that we found.
Yeah, thanks, Pippa. So to look at how hedgerows affect the soil structure and water movements, it's really important to understand the type of soils that we're working with, because the soil type will strongly influence how the water behaves within it. So in this study, we sampled 2 main soil reference groups, and a soil reference group is a broad category that is used to describe soils that behave in a similar way. And the first group we had is cambie soils, which are also known as brown earths, and they have relatively good natural drainage. And we had 11 pairs of fields and hedges on this type of soil. And then the second group was stagnosols, which are also known as stagnogleys. And these are much heavier soils that also drain much slower and poorly, and they tend to stay wet for longer periods of time. And we had 21 pairs of hedges and fields in these groups. So these are quite common soil groups across the UK, but also actually across all over Europe. So in the soil texture triangle here, you can see how the size of the particles of soils differ between the 2 groups. So we have the cambie soils that have a much higher sand content, which means that the water can move through the soil more easily. And then we have the stagnosols that are like triangle in purple, that have a higher clay content, which means that the soil holds water more tightly and it also drains more slowly. So the first property, the hydrological property that we looked at, is soil porosity, which is simply a measure of how many gaps, how many pores there are in the soil to hold air and water. And typically, the more pore space a soil has, and the easier it is for water to move through it rather than running off the surface. So in this figure, we see the porosity across the soil profile from the soil surface down to 50 centimeters for both soil types, in comparing the fields, which are in gray, and hedgerows, which are the green triangles. So overall, we can see that the hedges are always higher than adjacent fields. So if we consider all hedges together, overall, they were around 18% higher in porosity. But the two soil types behave differently along the soil profile, because you have stagnosols for which this difference was significant at all depths, so between 0 and 50 centimeters. And instead in cambisols, the significant difference of porosity was only down to 30 centimeter depth. So hedgerows consistently increase soil porosity, but the two soil types behave differently. And this is something that we will see for all other properties we looked at. The second property is the saturated hydraulic conductivity, also known as KSAT. So this property measures how quickly water can move through a fully wet, so a saturated soil. Very simply put, the higher the KSAT value, the more easily water can drain in a fully saturated soil, rather, again, than running off the surface. So in the figure, you can see the KSAT values for adjacent grassland fields and for hedges of different ages for the two soil types. So the first thing that you can see is that the fields, so the gray box plots are lower compared to the hedges, which are in green. For cambisols, the difference is very strong. So we saw that water moved through the soil 52 times faster under hedges. So this translates to, if you consider fully wet, so fully saturated soil, the water would move under the hedge at 52 millimeters per hour compared to just 1 millimeter per hour in the field. For stagnosols, we also see a large difference, but if you compare fields and hedges, because hedges were around 45 times higher compared to fields. But overall, the KSAT values in the soil type were much smaller. So on stagnosols, fully saturated soils under hedges could drain 4.5 millimeters per hour compared to 0.1 millimeter per hour in the field. So another interesting aspect of this that differentiates stagnosols from cambisols is how the change develops over time. On stagnosols, we observed that new hedges, so hedges that were planted 2 to 5 years prior to this, were not significantly different compared to fields, and instead they were in the cambisols. So this means that heavier soils are slower to respond to hedgerow planting. So hedgerows grow and the root system develops and the soil structure does improve, but it does take longer and it's not going to be as big of a difference as on well-draining soils. Here we're looking at how water flows through pores of different sizes in the soil. So we have, in the soil, we have different types of pores, and typically large pores or macropores are the pores that are essentially large gaps in the soil that allow water to drain very quickly. And instead, smaller pores, which are mesopores and micropores, are able to hold water for longer. This stacked bar plot looks a bit busy, but I'll guide you through it. So the first thing to look at is the two field columns. And you can see that the dark green proportion, which is the proportion of macropores, is much larger than in the hedges. So that means that in the fields, the water movement happens mostly through these macropores. And this means that water moves very quickly through the soil profile, which also means that is not very retained by the soil. So in case of an extreme rainfall, the fields are not going to be able to hold that water for very long. Under the hedgerows, instead, the pattern is different. And because we see that the light green and the yellow bar are comparatively larger compared to the fields. And this is because most of the water, well, a larger proportion of the water movement under hedges happens through meso and mycopores. This means that the water doesn't move as quickly and is stored in the soil for longer. And so this means that hedgerows can improve the soil's ability to retain water in case of heavy rainfall and regulate its flow more slowly. Finally, we can look at aggregate size distribution. This property describes how large are the clumps of soils. We can classify them into different size classes, from quite large, from above 2 millimeters, to very, very fine. So here we're at the micrometer scale. And generally speaking, larger and stronger aggregates are very important, and they're a symptom of a healthy soil, because they help the soil resist erosion, they support better movement and also better root growth of the plants. So the bar plot here shows the proportion of the different aggregate size classes in fields and under hedges of different age, and under hedges that are mature, so over 10 years of age. And that's because under new hedges, we didn't see as much of a difference. So this is really something that happens as the hedge grows and mature and creates that soil structure. So on cambisols in particular, mature hedges had about 14% more large macro aggregates, and at the same time they also had fewer medium and small aggregates. And so this indicates a shift towards a better structured soil. And instead on stagnosol, the situation was quite different. So stagnosol, as we said, have a much higher clay content, and clay is a very fine particle. And we observed, we didn't find a statistical significant difference, although it was nearly significant. But in general, we observed a slightly higher proportion of larger aggregates under hedges, also on stagnosols. So overall, this suggests that mature hedges can promote the formation of this larger and more stable soil aggregates, particularly when they're found on well-drained cambisols. This was a lot to go through, but this is a visual representation of what I just showed you, and it's essentially all the different soil properties that we looked into, and it's a measure of how different they were in cambisols and in stagnosols under hedges compared to fields. And the largest difference overall is really the KSAT, so the saturated hydraulic conductivity, which in both soil types was the largest, the property that measured the largest difference, and particularly on cambisols, so on the well-drained soils. So in the soil under hedges, we showed that hedges can improve soil structure, and particularly they can increase the large macro aggregates and soil porosity. We also showed that saturated hydraulic conductivity is higher under hedges than in fields, and it's always a substantial difference compared to the fields, but the effect is much stronger on already well-draining soils. We observed that the macropore floor decreased, meaning that the medium and small pores played a much bigger role under hedges than in fields, slowing down the water flow and meaning that hedges can hold water for longer. And the increase in infiltration rates that was associated with planting hedges was faster on cambisols than on stagnosols. So on stagnosols, it took at least 10 years for the difference to become significant. So far, we have looked at what hedges do in the soil right underneath them. But as Pippa said earlier, there is the larger question of what does this mean when we zoom out to the scale of whole fields, of catchment of the landscape. So one of the most important aspects that Pippa mentioned is the orientation of hedges and how they're positioned on slopes. So hedges that are perpendicular to the slope can essentially act as a small barrier. They slow down the surface runoff of the water, and they can also trap sediment that is moving downhill with it. So they slow down the water and they stop it from flowing really quickly into the river streams, and potentially they thus alleviate flooding. And in contrast, if we consider instead hedges that are parallel to the slope, the water simply moves past them, and so their effect on runoff is much smaller. And so far, there has been a lot of anecdotal evidence stating that when agricultural intensification happened after the war and the war, and we made fields larger and we mechanized agriculture, hedges were preferentially removed when they were running across slopes, because it would be easier for a tractor to go up and down the slope rather than parallel to it. But we didn't really have a way to check this, so we really didn't know if this was true or not. And this has changed because this year there has been the release of a new national hedgerow map for England that was released by the UKCEH, and it's a leader-based map. It's very detailed. It also classifies hedgerows based on their height. And this allows us to look into the question of what is the preferential orientation of existing hedges in the region. So we looked specifically at the Aden catchment, which is where all the hedges that we sampled were from. So this is the catchment, the largest catchment in Cumbria. And using this new national hedgerow map, we looked at how hedges are distributed effectively across different slope categories and what is their orientation relative to these slopes. So the first important thing to keep in mind is that the average hedge density in the region was 2.9 kilometers per square kilometer. But it's very important to note that the density was not uniform across the landscape. So here in this plot, if we look at the size of these dots, they indicate how many, this should be, how many kilometers of hedges were present in each slope category. And we see that most of hedges were on flat or almost flat terrain, so between 5 to 10 degrees slope. And there we see around 4.4 kilometers per square kilometer of hedges. And then the amount of hedges decrease as the slope gets steeper. So there are simply much fewer hedges where the slope becomes more steep and more challenging. The other aspect to look into this, in this plot is where the dots stand. So in this plot ranges from 0 to 90 degrees, and 0 means that would mean that all hedges run perfectly parallel to the slope, and value of 90 would indicate that all hedges are perfectly perpendicular to the slope. What we see here instead is that the blue dots are always right in the middle, and that the spread of the hedges, which is the light blue area, is very wide and is virtually the same across all slope categories. So what this means is that the mean orientation is pretty much 45-degree angle, which means that hedges are not predominantly oriented either parallel or perpendicular to the slope. They're just very consistent and spread evenly across different orientations. So when we think about natural flood management, there is one key message which is really simple and really important, is that new hedges planted for natural flood mitigation strategies should be preferentially planted perpendicular to the slope to maximize their ability to intercept runoff. And I think Pippa can walk you through some more. What does this mean in terms of catchment-wide approach?
Thanks, Sofia. So as you can see, we really looked at the soil properties under hedgerows of different age categories. And as Sofia said, we looked at the hedgerows that are currently present within the Eden catchment in Cumbria. But I think, as we all know, for natural flood management, there's a whole range of techniques that can be deployed within a catchment to help manage flood risk. And I think these are just some visuals, and there's the Flood Hub website, which really highlights some of these. So we can look at, there's a whole range of in-stream things that can be carried out, and woody dams. There's blocking of moorland drains in peatlands. There's planting of trees. So obviously what we're advocating, that on their own, hedgerows, are not on their own going to be able to mitigate flooding, but as part of a wider catchment approach, they have a role to play. And I think that's an important message. So the next slide is really to highlight that, one of the aims of NFM is that they have multiple co-benefits, and hedgerows really do have multiple benefits. And here's a word diagram. I think this was carried out at a workshop I attended, where people wrote down the ecosystem services, or the benefits that hedgerows provide. And through the work that Sofia and I have done with Guy and Richard, we can show that hedgerows do store more carbon than agricultural fields. They're able to sequester carbon from the atmosphere. They are important for farmland biodiversity. And here we show that they can increase infiltration rates and contribute to flood alleviation. And they're also important for climate change resilient from an agricultural farm business role. So really summing up, in conclusion, we can see that, as Sofia said, when we have improved grasslands, we tend to have less macro aggregates, we've got less carbon coming into the soil, and the soil structure is poorer. But where we plant hedgerows, we improve the rate of carbon that's coming into the soil. This has an impact on the soil structure. We get larger macro aggregates and porosity. This leads to a decrease in macro flow, but we still improve infiltration rates. And as Sofia said, so we're improving infiltration rates, but hedgerows are also able to hold on to that water for longer, so slowing the release of water, which is important, obviously, within NFM. But I think what we've highlighted is that it does matter where you place these hedgerows in the landscape and on what soil type. So on well-draining soils, you have a much bigger rate and magnitude of impact on the hydrological response. So, as I said, hedgerows can play a role in NFM within a broader catchment scale approach. And as Sofia highlighted, it does really depend, the benefit is higher when we place them perpendicular to the slope. So just like to say thank you for listening. And if you've got any questions, please do put them in the question and answer on that you can access here. I'm happy to answer any questions. Thank you.
Thank you, and thank you, Sofia and Pippa, for this really great webinar. There is quite a lot of really good questions that have been popping up in the questions and answers. If we answer some of those, I think Pippa already mentioned that definitely hedges have more core benefits besides the change in the hydrological properties. In the link that if you go to the YouTube channel of the Global Food and Environment Institute and you search hedge, you will find a couple of other YouTubes that actually Sofia and Pippa delivered in the last year, looking at the effect of hedges on soil organic carbon sequestration that were all done as part of that Resilient Dairy Landscape project that this was part of this work as well. So I'll start off with a question that was raised on the chat. I would say, how do we manage both existing hedges to improve what they deliver, or the benefits we have from them, on one hand, and on the other hand, I would say, when we are planting new hedges, there might be effects on the way we plant them, the practices we use for the actual planting itself, that might have at least a short-term effect. And then maybe the long-term effect is what we see in the study on like 10 years onwards. But especially perhaps on cambio soils, maybe the reason for the very immediate impact was more due to the way the soil was disrupted by planting the hedge. So any thoughts or ideas about those two, the planting itself and then managing existing hedges?
Yeah, really good question, because obviously, like as Sofia highlighted through that map of England, about the hedgerow densities and where they're located in the landscape currently, they're providing multiple benefits. And I think what we really show is that soil structure is really important, and soil structure is responding to carbon inputs and sort of the biology of those systems. So I think where we have hedgerows that are providing a lot of litter and root input, then that's going to help change the soil structure in a beneficial way. So I suppose where we have slightly larger hedgerows that have a lot of litter fall, then the rate of carbon input is faster than where we have quite small, well-trimmed hedgerows. So I think we can manage them to improve the rate of carbon uptake into the soil, and that obviously has an influence on macroaggregates and the soil structure and the hydrological functioning. So yeah, management is important. And hedgerows are different in different parts of the country. We need to acknowledge that. And I should say that we focused, the research we did was on hedgerows planted into soil around the edges of the fields, and not into banks that you get in some parts of the country, or stone banks. So those again would probably behave very differently. And I think really it's highlighting that if we are looking at hedgerows to play a part in flood mitigation, it's preferential to plant them as much as you can along perpendicular slope, or along observed well-known flood overland flow pathways, so you can intercept as much as the water as possible.
Thank you. Yeah. So there were a couple of questions around. There was a question around the choice of species in hedges, and I would maybe add to that the question of management, which you just mentioned. I think you alluded to the fact that what we think is the main mechanism is the carbon in litter, carbon from roots and litter that is going into the soil. So would you have any predictions on how tree species composition in hedges, or the way that the condition of the hedge will affect those hydrological properties?
I don't know, Sophia, if you want to say it, but I should say that the majority of the hedgerows that we looked at were dominated by hawthorn and blackthorn. And this is a common question that we've been asked on other webinars we've done in relation to carbon, again, about does the species of makeup of your hedgerow have an impact? I suppose it's there's more we could do, and there's more research, but those are the tree species the shrub and hedge species we've predominantly looked at.
Thank you. Yeah, there's, I guess, some of the questions were more about what do we do around in the rest of the fields. I mean, how do we manage the rest of the fields, especially if we have problems of compaction? I know this is an active research area. That's there is questions around whether we should aerate fields or not, and there's some disagreement, let's say, between certain actors, especially in the UK, on whether we should do it or not. I guess, Pippa, you've already mentioned that hedges is just part of the solution, right? That's not. That's going to be. There's going to be a mixture of things to look at.
Yeah, and soil management is also, considered part of an FM approach. So, aeration has its role to play, especially in compacted soils, where you've had maybe high livestock numbers and you feel your soil's compacted, then aeration is a technique that is being used to try and improve, the porosity of the soil and thus the, infiltration rate, like we've highlighted for hedgerows. And obviously, hedgerows only occupy a very small part of the landscape compared to obviously the fields, but if they're placed, appropriately, and they do surround many of our fields, they can, intercept some of this runoff and have a role to play. But yes, they are only a part, and there's, this natural flood management is really looking at the catchment as a whole and thinking about which different techniques to place where. It's all about, I suppose, the right hedge in the right place at the right time. It's the same with trees, where do you plant the trees, the best place for trees, or what species? It's the same for all of these techniques in a way. Where are they best placed?
Yeah, and in a way, this is where hydrological modeling comes in. So we provide one of the reasons why I wanted to study this is because at the moment, the hydrological models that are being used to design these sort of catchment solutions are based on very, very limited data. For example, without any sort of differences in soil type that are being considered. So we wanted to contribute towards those, but then it's really a job for the modelers to look at the landscape in a wider context. Here, for example, we can show that perhaps if you can preferentially, if you have a limited budget for hedgerow planting, for example, it might make sense to preferentially select well-draining soils that are at the upper level of the catchment, whereas it might make not as much sense to spend that money for lower catchment areas that are not well-draining soils.
Mm-hmm. Thank you. I think this is coming to the time of we had allocated for this webinar, and we answered, I think, the vast majority of the questions that were put in the chat. So just want to thank Pippa and Sofia again for this great presentation. So the recording will be available online on the YouTube channel. And thank you all for your questions and participation today. And see you in the next webinar. What was this?